The vertical angle theorem. The reason why I have this as its own video is because this is one of the most important theorems that we're going to work with this year. It is very commonly found throughout most of geometry. It's going to show up in triangles, it's going to show up in quadrilaterals, it'll show up in circles sometimes. It's everywhere, and it's a super easy theorem to use. Okay, first of all, we need to know what vertical angles even are. And if you check out the definitions page or the vocabulary page, it'll tell you that vertical angles are angles that are non-adjacent when we have intersecting lines. Okay, so what that really means is that they're across from each other. They're not directly next to each other. So for example, if I look at this angle right here, the angle that's non-adjacent to it, or in other words across from it, would be this angle over here. Okay. There's also another set of vertical angles. We're talking about this angle right here, and the angle that's directly across from it, or not touching it, would be this angle over here. So we know what vertical angles are. But we need to know what the vertical angle theorem says. What it says is that vertical angles are congruent to each other. Now, there's a proof for that. You can check out the proof online, or you can come and ask me and we can discuss it. It's actually one of the things that we did in our notes. So if you're not quite sure how to get that, I would check that out. But for right now, we're just going to live with the fact that vertical angles are congruent. Okay. By the way, we also have a way of abbreviating this. We call it VAT. Okay, so you're going to see VAT quite a lot too. Might want to check out and remember what that means. Okay. So let's look at a couple of examples. It tells us to solve for x if the measure of angle 1 is 13x minus 14 and the measure of angle 2 is 5x plus 22. Let's plug in that information into our picture. Here's angle 1, it's 13x minus 14, and angle 2 is 5x plus 22. Now that we see that they're vertical, we can use the fact that they're going to be congruent in order to solve for x. How do we do that? Well, congruency is very similar to the idea of equality. So we're going to think of these two things as equal to each other because they're technically the exact same angle measure. So that means they would be equal in angle measure. So we'll set them up like so. Now all we have to do is solve for x. I'm going to subtract 5x from both sides. It's going to leave me with 8x. I'm also going to, in this step, add 14 to both sides. That's going to leave me with nothing there. I have 22 plus 14 is going to give me 36. And my final step is to divide by 8. 36 divided by 8, well, this reduces. They're both divisible by 4, so this would be 9 over 2. Or for those of you who just have to see it as a decimal, that's 4.5. Okay, I prefer the fractions, but the decimals will work too. So here's another example for you. Notice this time that it's asking for more than just solving for x. It's also asking us to find the measure of angle 3 as well. But we're going to have to take care of that x thing first. So, if angle 1 measures 9x minus 5, and angle 2 measures 2x plus 30, notice how they're vertical, so we can set them up equal to each other and solve. 9x minus 5 equals 2x plus 30. Subtract 2x from both sides, and also I'm going to add 5 to both sides. It's going to clear out my constants from there. 7x equals 35. Divide by 7. That gives me x equaling 5. So that's the first part of this problem. It says solve for x. So we've done that. But it also wants us to find the measure of angle 3. Well, here's what I'm going to point out to you guys. If I look at angle 1 and angle 2, I should notice, I'm sorry, angle 3 rather. Angle 1 and angle 3, they create a straight line. They're supplements to each other. And what did we say about supplements in the last lesson? Supplements are two angles that add to 180. So I need to know what this angle is worth. And I can do that because I know the value of x. If I plug it in, it'll give me that angle's value. So let's check that out right now. If I do 9 times 5 minus 5, well, 9 times 5 is 45 minus 5, that's 40. So that means that angle 1 is 40 degrees. And again, we just said that they're supplements to each other, so I'm trying to figure out how much more I would need to go to get to 180. So real quick, 40 plus some value equals 180. Subtract 40 from both sides. It's going to give me 140, and that was angle 3 that we were looking for, so we would say measure of angle 3 equals 140 degrees. Okay, pretty easy stuff to work with. However, this concept you need to practice because it's going to show up everywhere. And if you don't get this concept, you're going to have a lot of difficulties when you start looking at much more complex problems. So that's the vertical angle theorem for you. I have it set separately because it is that important.